All right. Hello, wastewater treatment friends. We are here with tertiary treatment, which we're about to wrap up the wastewater treatment process. Tertiary is our last stage that deals with the liquid water part of our treatment process. We just have solids, residual management, I guess we'll call it, to talk about after this. So tertiary treatment. There is a lot, I guess I should say, a lack of consensus about what actually constitutes tertiary treatment. And there's a lot of people that, again, like I talked about with secondary treatment, we put disinfection, we put post-aeration into secondary treatment because we're at a spot, the water is good enough to discharge and we don't necessarily need more treatment. So tertiary treatment comes in when we just need a little bit more, which we'll talk about the reasons why that may be. But it's definitely not as common to have tertiary treatment, whereas secondary treatment is pretty standard. You need some microbiology going on to be able to properly treat water. So here's your delay. Oh, that was faster than usual. We are to primary textbook sections. So Mackenzie L. Davis is the only one that has like an actual chapter called tertiary treatment out of our 3 books. WEF designed the things that kind of fit under is side stream treatment as well as disinfection, and WEF operation is the disinfection chapter. There's things throughout that'll apply to tertiary treatment, but this might be somewhere where you do have to use online resources or something like that to dig a little deeper or rely more heavily on that disinfection post aeration, which again applies to secondary treatment as well and fell under those chapters, versus tertiary treatment is a little more compact, a little less big than secondary treatment. So, but the purpose, like I said, is that we just have needs beyond what can happen in secondary treatment. So things that may be causing that is that there's an increased load of organic matter and suspended solids to discharge waters. So maybe you're discharging to like a lake or a stream or a pond or whatever, and there's all of a sudden more organic matter and suspended solids. I shouldn't say all of a sudden. There's a buildup of organic matter and suspended solids being discharged to that body of water. And that comes from increasing pressure from population growth. So the water treatment plant is just getting too much organic matter and suspended solids, and the current processes as they are ending with secondary treatment don't properly meet those standards of discharge anymore. So we need to add tertiary treatment to be able to actually meet those standards. Second one is that we need to increase the removal of the total suspended solids in order to improve disinfection. So disinfection, you can read and study into that. Very interesting. Disinfection is fascinating to me. But we need to, especially when we're doing UV and need to have pretty clear water to be able to have contact with that light. If it's too cloudy, we know that the UV won't get through, but also chlorine. If there's too much flocculation and that sort of thing, the chlorine doesn't get to the spots that it needs to necessarily. So we need to clean it up further so that disinfection is more effective. Third one is to remove eutrophication nutrients. Those are phosphorus and nitrogen. And what eutrophication is when you get too many nutrients in the water, you can end up with algal bloom, which can be toxic as well because you had too much nitrogen and phosphorus. You can study deeper into that, also very fascinating. But we need to remove some of that nitrogen and phosphorus, which is ever growing in our bodies of water, and to prevent that eutrophication. Last one, we want to remove constituents that prevent water reclamation. This could mean different things depending on what we need to reclaim the water for. And so that's something that you can also look into. All right, examples for treatment processes. Again, this is not comprehensive. This is just what came from the Davis textbook and what I know more about. And there may be other things that are tertiary treatment. So examples here, chemical precipitation. So we're going to look at, similar to trying to remove phosphorus, nitrogen, those sorts of things, we're going to use some sort of chemical to remove a constituent that we don't want in our water. That's very chemistry heavy. Granular filtration, so think something like sand, a bed of sand that we are going to use granules of something to be able to filter what we need to out. Membrane filtration, this is going to be literally you have a membrane, you have some sort of filter that you are flowing the water through. Carbon adsorption. So this is, think about like activated charcoal. If you have like a Brita filter, maybe you've heard about carbon. Over on this right side, that shows one of our activated carbon filters and what the process is for using that in our wastewater treatment process. And then there are also advanced oxidation processes. So you can get much more into that, again, heavy chemistry stuff, if that is what is of interest to you. But basically, we're trying to remove the things that we don't want in the water to prevent negative outcomes downstream when we discharge this water. So design considerations. A lot of things similar to what we've talked about, but there are some new things because of filtration. So bed size and usage rate. So how much of this, especially if you have like sand or anthracite or carbon in a filter, how much is it being used and how much do we need to resupply and how often do we need to wash it, which falls into this third one, backwashing and cleaning the filters. How do we actually make sure that those filters or media are being taken care of, which brings in media selection. What are we actually going to put in it? Are we going to put sand? Are we going to put anthracite? Are we going to put carbon? What material are we going to use for our actual membrane filter? Those sorts of things, which if we are using membrane filters, we need to think about transmembrane pressure. So do we have too much buildup of pressure on one side or the other? And what pressure do we use to effectively filter but not ruin the filter? How do we not backwash or blow out all of the media from our filter? Those sorts of things. All right, jumping back up, hydraulic loading rate. You can also bring in contact time here. So actually, how much water can we put in? How much can it handle? Those sorts of things. Last one, disinfection and post-aeration. I add this on because it's not in the Davis chapter, but it can fall here because over on this right side, we have the sand or anthracite filter on the left, and that outlet then has to go into some sort of disinfection process, which this one is a chlorine disinfection process, so chlorination, but it's got to flow from the outlet and then it's got to go be disinfected. So you're going to have to look at that. You might have to aerate to add more oxygen. Again, you don't want to kill the animals or fish downstream. That has to be added on to tertiary treatment because you can't disinfect and get those things done and then send it through tertiary treatment. That still is going to be on the tail end of the process. Ideas for self-study. I didn't put a ton here because a lot of it ties to the design considerations and things we've talked about before. Things that are new here, you could do a case study for the types of tertiary treatment and why you may choose membrane filtration versus granular, or why you would choose carbon absorption versus sand, that sort of thing. The second one is looking at advanced versus tertiary treatment. This is where some of those arguments come in, is what is advanced processes, such as like reverse osmosis, maybe that's something that you've heard of, versus tertiary treatment, similar to things that we've talked about. What makes that distinguishment and where do we use those advanced processes versus tertiary processes? The last one is where I expect you to spend lots of your time, and I talked about some of these things in the secondary process, which is why I didn't put them here as well, but those disinfection and post-aeration considerations that come from the design considerations. So review, go back to secondary processes to get some of those ideas as well, if you haven't studied disinfection and post-aeration at length with the secondary treatment. So happy self-studying.